when he gets this. So basically, this is our revision practice deck of slides. So it's got 3 points here, 3 entries. So the first one, if you want to look for summary by topics, so let's say you've got a few problems, you've got to work through them, and you go, oh, there's a part that I can't remember. You click here, and here I've broken it down into all the different topics that you went through. Okay, so let's say you had a question on angles or shapes or similarity or Pythagoras, and you can't remember something. You say, okay, I'm going to use this, do a quick revision, you hit Pythagoras, and then it gives you a few things that you need to know about Pythagoras. So
right, okay, that's good.
what you know is basically if you were to calculate side length, a square equal b square plus c square, or now it's got these wee blank there, so it's all animated. So basically it's to let you do this work in your head first. And then if you can't remember, see the length a, b, and c satisfy that a square equal b square plus c square. So the longer side hypotenuse is the one opposite to your right angle. And then that means a is just square root of b square plus c square, or b square is a square minus c square, or c square is so you can find the lengths of smaller sides. So you can open all that and you can say, okay, these are the things that I need to know about Pythagoras. The next slide gives you a few examples, what kind of calculation you may get. So calculate BC, for example, to 1 decimal place. You would go, oh, I need to find BC. So that's an hypotenuse, so that's a long side. So I've got that side there, one of the short one, but I don't have the other short side. So that means I need to calculate this short side. Because the good thing about this right angle here, I've got a long side and a short side, and this is where you start applying that BD square is just the longer side 10 square minus 8 square. So you've got the answer there. But the fact that I've left it here is just to challenge you into trying to think about what do I need to do to get BD now?
Yeah.
Rather than just going through it. I think you may think I'm learning it, but math is not a subject that you learn by heart. It's better to understand what you do, remember? So BD, you'll find is 6. Now you've got BD, and then you're looking for BC, and Pythagoras tells me that BC square is BD, 6 square plus 3 square this time. So it's
Are you
40.
just going to send this out as a separate link on the email?
Yeah.
Yeah, that's fine.
So I'll send you this, but I'm just walking you through what Pythagoras would look like, all the questions that you can do with this one. So there's quite a few though. You've got quite a few questions, an application of Pythagoras and the converse. Yeah, so converse.
Wait a minute, we're now back to the trig homework on the screen.
Are you?
Yeah, that's what you're sharing.
The trig homework. Let me make sure that it's not there. So is that what you see?
Yeah, that's what we see just now.
That's strange.
We did have it before that.
Yeah, so let me close the trig homework because we don't need it now.
Yeah, the reason I was asking about that link is that would be quite good for before prelim or whatever.
Yeah.
To go through once we've done unit 3, having a easy, quick reminder.
So can you see what I'm sharing now? The converse of Pythagoras?
No, you're not sharing the screen at the moment.
Okay. I thought I was sharing.
I'm watching the screen. I've got 2 screens here, and the bigger one's better for my side.
So let me share this. Oh, is it because I was sharing the PowerPoint rather than sharing the whole screen? Yeah, so.
That's it now.
Okay, yeah. So converse of Pythagoras is another thing that you may be asked. So an example of a question is you've got a picture that was framed 18.6 by 24.8, and someone measured the diagonal at 31 then the question you were asked here is the frame rectangular? So when you've got a right angle, you know that the diagonal square should be equal to each of the smallest side square added together. So what I'm going to do here, I'm going to calculate first 31 square, and I'm going to check what 31 square is, and I can calculate as well 18.6 square plus 24.8 square, and I've got 961. So now that I've got both equal, then I can say using the converse of Pythagoras, so I've got a right angle triangle, the frame is rectangular. So you don't need to write all these triangle. You just say using the converse of Pythagoras, the frame is rectangular because you've proven, you've proven that there.
Yes.
You need to do one calculation and another one where you add those. And that's how you would answer this question.
Okay.
Okay. It's funny, on Facebook, someone had put the converse of Pythagoras and put one of those shoes in front of Pythagoras, the converse shoes. I thought that was quite funny. And then I've got some basic angles facts as well that we looked at. Angles around a point, complementary angles
Yep.
to 90,
180.
supplementary angles 180, all angle in a triangle add up to 180. So you could build your own flashcards if you want. Don't need to, this is very detailed, but if you could have a wee flashcard that summarized that, and that at least writing it, I always found I got a better picture memory in the back of my head by doing a bit of writing myself. Some people are okay to read, some people would learn better, you know, with sensory or listening. So everyone has got his own. Again, you can play with all these, and you've got a few questions with solutions, angles in parallel. So you've got what we call F angles, Z angle, and X angles. Again, three things that you could write on your flashcards for angles, and a couple of questions that comes with it. And then the different types of triangle. What do they have? Isosceles, and then when you got parallelograms or a rhombus, what it looks like, and a kite.
Yep.
So there's all the different angles that you could be thinking of that are put in, and the kite, and then a couple of exercises. So if I was to go back, you could see that one topic is probably about 10 different slides, but bear in mind there's few examples associated with them, so that gives you the chance to practice the type of question.
Yep.
So that's the first part, is for you guys to be able to navigate through, click on what you need to work on, for example. But what I wanted us to work on today is looking at some revision questions by topics. So we can come back to the topics if we try a question and we find it quite hard, okay?
Okay.
So let's go into revision questions by topics. So you would click in here, and these are the type of question that you could get asked. Find the equation of a straight line passing through the point 2, -1 with a gradient -1. So what we could do is I'm going to pause recording. So if it's not given to you and it's completed the square form, the other thing that you get from this is what we call the roots. Okay. And the roots is the x-intercept. Rather than being the y-intercept, is going to be x-intercept, which is 0 equal x minus 2 times x minus 4. So this is equal to 0 when x equal 2 or when x equal 4. So I know from this I've got a root at 2 and a root at 4. And because I've got x times x, which is x squared, I've got a happy face. So I'm going to get a minimum turning point. Yeah.
Mhm.
So to start drawing this, you would go, I've got axis here, 1, 2, 3, 4. So I've got 2 points. That's when y equals 0. I've got x equal to, and the other thing is, where do we cross the x-axis and the y-axis? So we've told them where we cross the x-axis. So you can say that the points here is going to be 2, 0,
0,
and
4.
4, 4. So it's always x first. So these are my 2 points here. So we will cross the y-axis when x equals 0. So if you get x equals 0, you get -2 times -4, which is +8. So if you go 1, 2, 3, 4, 5, 6, 7, 8, this is where you'll be crossing the y-axis. Okay. So now x0, y equal 8. So 0, 8. That's my point there. How do I find the coordinate of my turning point? The turning point is halfway between the two roots. So if I've got 1, 2, and then 1, 2, what's halfway between 2 and 4? So you've got a 1, but then what does it mean if you got a 1 there? What do you get for x?
Half.
So yeah, so this is 4, this is 2, then that means x has got to be equal to 3. So the turning point, x equals 3. So replace x with 3, y equals 3 minus 2 times 3 minus 4. 3 take away 2 is 1 times -1, which is just -1. So at -1 there for y, so x equals 3, -1, you've got your turning point. So I've got root, turning point, and y-intercept. So now it's just a matter of drawing all these and joining them up and going back up. And that's x, and that's your y coordinate, your y-axis there. Okay, so you notice how we did it. Show clearly the coordinates. So you need to show that on your graph. The coordinates, not just doing the math. You need to show it on your graph. Show the y-intercept there, y-axis. Showing clearly where it crosses. So they didn't ask us for the coordinates, so you can just put 2 and 4. But if you want, you can put 4, 0. It's not going to take you points from it. And you can put 2, 0 as well, just if you want to be consistent. So you've got 2, 0, 4, 0, and so on and so forth. So let's see how they did that. So the first one, we did that okay. The second one, we drew 2 and 4, then 3, -1, turning point, and 0 and 8, which is the one that we've got there. So have you noticed the way they've answered this question? They've only put the coordinates when they were asked to put the coordinates. So that's why you got 3, -1 here. And that is your graph that we've just drawn. It's a different scale, right? So you can see here they've chosen a much smaller scale, 1, 2, 3, 4, 5, 6, 7. So you, remember, it's only a sketch, whereas here I've tried to make the scale, both the X and the Y, the same. So this is 1, 2, 3, 4, 5, 6. Okay. So that's how you would draw the graph, or you would sketch a graph. Any question? Two ways, yeah. Completing the square form or this way. So use the quadratic formula to solve x squared plus 7x plus 2 equals 0. Oh yeah, whenever you see use the quadratic formula, so it's in your formula sheet. So you'll see the quadratic formula tells me that the answers are minus b plus and minus square root of the, remember the discriminant? B minus 4ac, yeah. All that divided by 2a. So this is going to be given to you. So first thing first, you need to identify what a is, what b is, and what c is. Remember what we said in math? They never write that invisible one. So that's what a is for. So a equal 1, b is 7, and c is 2. So the first thing I'm going to do is I'm going to work on my b squared minus 4ac just to make it easier for you. Remember, we're trying to minimize mistakes here. So b squared is 7 squared, which is 49, minus 4 times 1 times 2. So 49 minus 8,
41.
and that's 41. So you've made your life much easier by just writing the discriminant. Now, my two values are going to be x equal minus b, so minus 7, plus root 41 divided by 2a, which is 2. So that's easy to do on your calculator, I hope. So if you type that, you get a value. If you want to give 3 significant figures, or if you want to say, I'm just going to give it to 2 decimal place, it's up to you.
22.41.
And then the other one is negative 7, negative minus 41, minus root 41 divided by 2. So let's see how they give that. So a equal 1, b equals 7. So minus 7 plus and minus 41. So negative 0.2984. So they've given it to 2 decimal place. So sometimes you see that written means they've rounded it, but you need to say to how many. So if you say 2 decimal place, you would put 0.30. If you don't want to worry about knowing how to round this, you can just say this is, you could have just said this is negative 0.298, 3 significant figures. It's up to you. If they don't ask you, you can just, then you've got less chance to make a mistake. Okay, just pick the one that you know you're not going to make a mistake. 2 decimal place, it's quite easy to make a mistake, right?
Yep.
People sometimes go, oh, is it 0.3 or is it 30? So this is negative 0.30. So the next one is negative 7, negative root 41, and 2 decimal place, which is 70, or 3 significant figures as well will be the same.
The one that, Adrian, sorry to interrupt you, the one that was in that formal homework actually gave me a bit of a headache. Like, I think there was one that was like, it was x squared minus 5x minus 7, and I think I was going through the whole process. It was just working out the b squared minus 4ac part. It was quite tricky, like negative numbers and some positive.
All right. So to get it okay, what you should do is you should say b square, so that's -5 square, so open bracket, -5 close bracket square, minus, then you go 4 times 1 times -7. And type that exactly in your scientific calculator. Exactly the way I just wrote it there. If you type that in your calculator, then you should get the answer. Because that's going to do a positive 28.
Yeah, I got there eventually because I kind of did a longhand without using my calculator, but I got -5 plus or minus root 53 divided by 2. So I got there eventually, but it was quite like, there's a lot of things to manage there. But
I got a couple of mistakes by putting in the calculator, not doing it step by step.
Yeah.
In the route.
It's not it's I maybe possibly agree, like it's not not knowing the way to do it. It's just, you know, some like little things that
it's like stupid mistakes.
Yeah, the common one seen is people forget to put the brackets there, and then when they type it, it comes -25 instead of the positive 25. Whereas if you do -5 times -5, you get a positive number. Or sometimes they forget that it's a -4 times a -7. So that could be another one.
Yeah.
Okay.
Thank you.
So on this, that was problem 1. So if I move to problem 2, to solve the equation, you just need to make x plus 9 equals 0. Or x minus 1 equals 0. So x equal -9 or x equal 1. So that's how you solve this equation. It's one or the other, but you need to give the 2 answers to get the mark. Okay. Because remember, when you do a times b equals 0, it's either a, which is 0, or b equals 0. And that is exactly the same. X plus 9 equals 0 or x minus 1 equals 0. And that means you've got 2 answers. Okay. That's how you would solve that. Discriminant, that's what you were just mentioning here. How do we find the discriminant? So you identify A, B, and C, and discriminant is B squared minus 4AC. B is -1, so you type -1 square on your calculator, minus 4 times 5 times 1. So -1 square, that becomes +1.
1.
-4 times 5 is -20.
Yeah.
And straight away you can see that you've got a negative number. So nature of the roots, whenever you see this question, nature, calculate the discriminant. If it's negative, no real roots. So that's why you should be writing there, no real roots, because it's negative. Okay.
Yep. Got that. Remember that.
So that was quadratics. Any question on quadratic?
Practice.
So we've got a little exercise with angles and similarity. So now look at the question there. Do 3 rods measuring 14.1, 25.9, and 30.1 make a right angle triangle when placed end to end? So what I would say is the first thing first is we're going to put these rods end to end. So let's try and draw a diagram, right? So we've got this rod here, another rod, and the longest one is this one. So I've got 30.1, 14.8, and 25.9. Now the question asked is, if I put these rods like that, and that's the length of each of them, is this angle 90 degree? Meaning, do we have a right angle here? So what is the theorem that we said we were going to use whenever we're going to be faced with a right angle triangle?
Squared plus A equal to AB, A squared plus B.
Yeah, so Pythagoras tells us that if this is A, this is B, and this is C, if it's right angle, C square, so Pythagoras theorem tells us that C square equal A square plus B square. So that's what we need to check. So what is C square?
14.8. It's 30.1.
So use your calculator, 30.1 square, that gives me 906
906.01.
in 01, yeah. Now I'm going to do A square plus B square, so 14.8 square plus 25.9 square,
889.85.
so 889.85.
85.
So are those two numbers equal?
No.
No. So you come over here and say, no, that didn't work. And the answer you would put is, based on the reverse of Pythagoras, this is not true. So which Pythagoras theorem is not true? Therefore, we don't have a right angle, because C square is different than A square plus B square. So if you were to draw this and just put C square different than A square plus B square, then not right angle triangle. That would be enough. You've just proven that 906.01 is different than 889.85. Okay. So this is a triangle, but it is not right angle. It was close, but not quite.
Not enough.
Not enough, yeah. So if you want to put some shelf with a proper right angle, then you would do something. Make maybe this 125.9 a bit longer. So that was question 1. Question 2, it's all to do with, remember all the things we did with angles in a circle. So whenever you're going to get the center of your circle and you'll see a tangent touching the circle, so the line between your center to the point where the tangent is touching always makes a right angle. So that's the thing that you need to bear in mind.
Mm-hmm.
And because they are right angle, that means this is 90 and this is 92. 90 plus 90 is 180. And in any quadrilateral, so 1, 2, 3, 4, any shape with 4 sides, all angles added together should be equal to, so PCR is this angle missing there. So PCR, which is the angle we're looking for, plus 90 plus 90 plus 43 equal to,
223.
sorry,
223.
so
223.
let's think about that. If you've got a rectangle, what's this? 90.
90.
What is this?
90 as well.
What is this?
90 as well.
And then the last one. So any quadrilateral, when you add all the angles together, do you get, what is the
360.
360?
360 for your total.
Is that what you said? I didn't hear you.
No,
Yeah, I was adding up the,
I was adding up 90 plus 90 plus 43. That was only giving
Okay.
you 223.
Yeah, so that would be 223. Yeah, you can do that. And then you find what is PCR.
360 minus the 223.
223, yeah.
Yeah.
Is that the angle for QR? Not QR. Yeah, no, QCR.
So it's PCR. You always put the letter in the middle. Yeah, the letter in the middle is where the angle is. If you put that,
That would,
or
yeah, that would
sometimes,
make that 137.
yeah, you see some book putting them like that with a wee hat at the top. That is the same. So it's a sign that they use for angles. So let's see. The sum of the angle should be 360. We found the 223.
Yep, that's right.
Yeah. So you see, I wouldn't write it like that. I would put here PCR, to be honest.
Yeah.
It's just some books. Maybe I'm a bit OCD, but it's just to get it right, we use 3 letters to identify an angle. So this is QRC, and the last one is CPQ. Yeah, use 3 letters to identify an angle. And the letter in the middle is where the angle is. Okay. So easy enough with angles.
Yeah.
What happened there?
I'm quite confident in angles.
Where's my PowerPoint?
Go.
Down the bottom, I think. Right down the bottom.
There you go.
Yeah.
Good. Can you see it back? Yeah.
Yeah. You just need to make that up.
So harder questions, but this is using what we did when we did similarity. Remember the linear ERF reducing factor or enlarging factor. So we've got 2 cups. The larger cup, 20 centimeter high, holds 225 milliliter. So that is my cup there.
Scale factor.
Yeah, so you need to find those scale factor. I'm trying to get the pen to write. So you've got 2 cups. One is holding 225 milliliter. And the question is probably, how much does the smaller cup hold if it has a height of 16? So we're going from a big to a small. So we need to use what we call the reducing scaling factor. And we said that RSF, sorry, is 16 divided by 20. So even, 8 divided by 10, even, I'm gonna have them both 4 divided by 5. Okay, so there's a ratios, so it's 4/5 the reducing scaling factor. Okay, now we need to be careful here. How much does the smaller cup hold? They've not asked us how much the length is. So anything that you see in milliliter is equivalent in something cube.
Mhm.
And what is cube again? It's not an area, it's not a length, it's a
Volume.
volume. Yeah, so this is the bit that you need to be careful. So a question like that could happen because people won't think about this being a volume, because whenever you've got a volume, you need to use your scaling factor and cube it before you time to the next volume. Okay, so that was the only difficulty here, is to realize that they are asking you for a volume. So a volume can be given in millimeter cube or centimeter cube, or in what they call the water or the liquid unit, which is liter, milliliter, etc. Okay, so this is what you need to be doing: 4/5 cube times 225, and that's going to be our answer here. Let's check it. So scale factor for volume, you need to cube it, then you time your cube scale factor with 225, and that gives us 115.2. Okay. Next, I've got a wooden puzzle which got 3 large pieces, and they are heptagons. So it's got 7-sided shapes. So 1, 2, 3, 4, 5, 6, 7. Calculate the shaded angle indicated on one of the larger piece. So whenever you see this, ignore all these. Just think about they're not here, and just work with what you have here. So angles round a point. What's the total angle around a point is?
360.
360. So first thing first, I'm going to put here what I know, 360. Because it's a regular heptagon, means all these lines are equals. So they're all equal. So because they're equal, that means you've got an isosceles triangle. And whenever you've got an isosceles triangle, you've got 2 sides that are equal, but you've got 2 angles as well that are equal. And you'll be able to notice that these 2 here are just the sum of that one plus that one.
Yep.
So if we can find one, we can double it, and that means we can get the other.
Mhm.
Okay, so first of all angles in a triangle add up to,
180.
yeah, add to 180. Because we've got 7 shapes here, sharing 360 degree, each of them will have how many degrees here? 360 divided by 7.
51.43.
Could have made it a bit better, no? Could have made it a bit simpler.
51.
I know.
Right.
So
It's rounded.
51.43 with 2 decimal places, you can say. So now what you have is, because you've got 51.43 plus the 2 angles that are the same, or plus that brown one, we're going to call it, let's call this big angle there alpha, equal 180. If we add them both, so you've got 1, 2, and 3, the 3 of them equal 180. So what is alpha is the question they've asked you. So to get rid of something that's been added to alpha, you take it away on both sides, yeah?
Yep.
And that should be your answer.
and 30.
180 minus answer is 128.6. Yeah.
Yep.
Or you can leave it as a fraction, 900/7. Should be okay too. You can say that this is just 900/7 if you wanted to. Degree. Or you can just say, I'm going to write this with 2 decimal places, but you need to state 128.57 degree with 2 decimal places. Okay. So angles and similarity are not the hardest, but you just need to watch the question that you've been asked. Shaded angle 128. So they've given it here to 1 decimal place. We haven't done better. We did 2.
Well, I didn't ask.
I know.
And asked it.
Now we're just going to finish with what we've been doing for the past week. Solve the equation 3 sine x minus 2 equals 0. And you've been told to use the answer between 0 and 360, which is good because that means if you use the cast diagram, you only need to give the answer. Okay, so you would go cast. Before looking at this, you need to solve this. I've got take away 2. What's the opposite of taking away?
Add that either
Add.
side.
So I've got now 3 sine x equal 2. Then to get rid of a 3 time, you divide by 3. That becomes a 1. Sine x equal 2/3. Well done, that is positive. So it's going to be where it's all positive. And in that quadrant 2. So you would say x, I need to find, and 180 take away x. Because remember, I'm on that second quadrant. So x equal inverse sine. So if you do that in your calculator, you put the fraction 2/3.
41.81. 41.8 to 1 decimal place.
So 41.81.
Yeah.
With 2 decimal places. Yeah. So that'd be your first one. And then the second one is just x is 180. Take away that. Which is 138.19.
Yeah.
So you've got your 2 answers there. You can put a wee degree here if you want. X in degree, just to keep us all right. Let's check that the answers are okay. 41.8 to 1 decimal place, 138.2 to 1 decimal place. Okay.
Yep.
So you see here they've put is in the first and second quadrant because they didn't put the cast diagram. So if you put the cast diagram, you don't need to write all this, as long as you show you're working how you got the first one, the second one. Okay.
Yeah.
Second one, sketching. So whenever you've got to sketch, you look first. So I've got sine x. Okay, so sine x is one of the easiest one to do. It's probably the easiest one, but then you need to move it up by 1. So just think about what sine x looks like normally. So if sine x is between 1 and -1, yeah?
Yeah.
So just put it onto a wee sketchy on the side. So this is 1 and this is -1,
Okay.
360 and 180. So think about that one here. I'm going to add 1 to it. It goes to 2. That 0 there, I'm going to add 1 to it. It's going to go to 1. That 0 there, 1 to it. That -1, if I add 1 to it, it becomes 0. And that one there will move up there. So your final answer, with a different color if you want, or a pencil that you can rub out the first one, should be like this. And it goes up to 2. And that's it. So you can rub that out from your paper and you've given sine x plus 1. So that's how quickly you could put sine x plus 1. So what I've done is just moved it up by 1. And at 270 now, that's where you touch that. But the amplitude is still 1. So if you were to look for the amplitude, it's just this value there. That's why it's sine x just means 1 sine x. Okay.
Cos is through the points of, is cos through the points of 180 and 360. Am I getting myself mixed up? It's sine not 19, 270. I'm talking.
Yeah, so for me, whenever I see a question with cos, I put, if I can't remember what cos looks like, I put the sine and I just shift it by 90 degree. So because this is 90, if I shift it by 90, that point will arrive here. And that's what your cos looks like. It's just shifted by 90 degree. So imagine if you had a sine and just shifted by 90 degree, what would it look like? Stop there, but then you carry on because the whole thing has been shifted. So shifted to the left is plus. So basically, cos x is just sine x plus 90. Shifted to the left, you add 90. It's plus 90. So if you remember the sine signal, and you know how to shift them to the left plus to the right, then you should be okay. Oops. So for the last question, we've been asked to find the amplitude and the period. So remember what we said. Normally a cos is just 1, so the amplitude just becomes the number in front of it. And I've got 2 signals within 360. So you say 2 signals within 360s.
Sorry to interrupt you. You can see when it, in some of the questions it says write down the period for.
Yeah, so they're asking for t.
Yeah, that's just like
Yes. Yeah, so t is just 360 divided by that number.
Yeah, okay.
Or if you can't remember, just think about, I've got two signals within 360.
Yeah.
So that means I can put 1 signal within half of 360, which is 180.
And then the other, so that's 2. Right.
So period 180, amplitude equal 3. So let's have a look. Amplitude is 3 and the period is 180. Okay, so it's good to know because sometimes you can be asked, draw that signal. So you need to remember that you need to draw 2 of these within 360 with an amplitude of 3. Whereas when I tell someone, oh, the period is just 360 divided by that number, one day they're not going to remember what that number is. Whereas if you tell them you've got 2 of this signal within 360, it's a better picture. So because if you got cos like that, then you do cos again twice, and then you've you've drawn now cos here 2x.
Yeah.
Because you've got two of them within 360. And now you can see, oh, the period is just half of it, it's 180. And the amplitude would be 3. So instead of a 1, that changes to 3. And that becomes a -3. And this is y, and this is x. So that's how quickly you can draw a graph if you understand what each of these means, really. So I would rather teach the meaning of a graph than telling folks, just use this formula. Yeah, a formula, you'll remember it next week. Being able to understand a graph, you'll remember it for more than 6 months. Okay. So that was the different sample questions that we went through. So if you were to go back right at the start, then you can see sample exam questions. I've put a link as well there that would take you to more practice. So if you were to go to this site called National 5 site,
Yeah.
so if you click on that, there'll be plenty
Yeah, they've got loads.
worksheets and past paper questions, and you can even specify what you want to hit. Okay, so I've put that there. And the next portion would just be sample exam questions. Okay, but
Okay.
they are associated with Unit 2. So I'll try and do the same for a Unit 1 summary, so
Yeah.
that means you'll have both.
Yep. That's
And
great. Thanks very much.
You can use that for when you do revision work and stuff.
Yeah.
I'm gonna
Because I might not sit and do like all of Unit 2 when it comes to like the end of